b of x equals y, what's the question? Like this question. This was what? What number do you have to raise 2 to get 8, right? Or in other words, this is the same thing as this. 2 to the 3 equals 8. Or if I write this, maybe I should write it like that. This is the same thing as this. Right? The x here is the same as the x here, right? So in other words, it's, here it's 3, right? Just like here it's 3. This is exactly the same thing. This is exactly the same thing as this. Right? Always. Right? Or in this case, just with more unknowns here, what? This is exactly... well, now I changed the x. I put x here. I should have put y here. Okay? Should have put y there. Okay, so now what? This is b to the y equals x, right? b to the y equals x. Right? They're the same thing. There's no difference. Okay? Any question about that? Okay. So, okay, then what's the inverse of this function? This function is the same as this function, right? Exactly the same function, right? If you graph this and you graph this, the same set of x and y's satisfy this as satisfy this, right? So the same graph, right? The same points, so the same graph. Right? So this has exactly the same graph as this. These are the same things. Right? Okay, so now I can ask you though, what's the inverse of this? And I'll allow you to use our trick. So what is the trick? So you can exchange x and y, right? So if we do that, if we exchange x and y here, what do we get? Okay? So this and this are inverses, right? Okay? Or this and this are inverses. So if I want to know the graph of this, or I want to know the graph of this, I know how to find it based on what we've talked about the relationship between the graphs of inverses. Right? And I already know the graph of this. We spent the beginning of our class doing the graph of this. Right? So, what is the graph of... Let's take a more specific example. Let's say when b is 2. Okay? Let's talk about b is 2. So that this b is 2, and this b is also 2. Okay, so anyway, what's the graph of this look like? Well, it's going to be the inverse of the graph of that, right? So what is the graph of that? Well, we already did that. Y equals 2 to the x, we already did that at the beginning of class. So we said it goes through here, and then it goes up like this, and goes down like that. Right? Did that. So, what's the graph of this? It's the inverse of this one. Right? So what's the graph of it? Well, you might not be able to see it so easily. A little bit hard to see, but I mean, it's just the reflection through there. Okay, maybe you're not so good at drawing reflections. I'm not very good at it, but I know that it looks like this. Okay? So, actually, this is 1, I guess. Okay? So that is the graph of y equals the log base 2 of x. Okay? And one more thing. If you do these two together, this one and this one together, what are you going to get? If you do their composition, what are you going to get? They're inverses, so you're just going to get x, right? So how do I write that? Because when you write it, it looks kind of looks interesting. But it really is just saying that one is the inverse of the other. In fact, what's the definition of this? The definition of this is this, right? Right? This, how do you calculate this? You just say, well, what do I have to raise 2 to get this? Right? So that means this. This is the definition of it, right? So the definition of this is just that it's the inverse of this, really, right? That's the definition of it. So it's not like so when we write out that when we do both of them together, it's going to look kind of amazing, but it really is nothing. It's just saying that we defined the log to be that way. We defined the log to be the inverse, so you have to get x at the end. But when you write it out, it looks interesting. So let's say g of x is the log function. How do we write it? The base log, I think the 2 goes here, right? X, yeah, that's right. Okay? Did I do that right? I think so. Log base 2 of x equals y. And the other one is 2 to the x. Yeah. Okay. So let's write out this. What is that? F of g of x. What is that? So that's 2 to the log 2x has to be what? X. So it looks like, that looks so complicated. Right? But it's not complicated, it's just saying that they're inverses. And the log was only defined to be the inverse, so it's not even saying anything. Okay? It's not complicated. It's just a fact. It's just a definition. And let's write it the other way. G of f. So how do I write that out? This also looks kind of complicated, but it's really not saying anything. So that's what? The log base 2 of 2 to the x equals x. Right? So those are not saying anything. Those are just because the log is defined to be the inverse of the other function. Okay? Of the exponential function. All right, so we know that we get statements like this, and we know that we get statements like this, and we know that the picture looks like this. Okay? Okay, so that's also, now we've studied the log function as well. Now, I think everybody knows that if you write this, what does E mean? What is E? That's just a number, right? 2.7 something. Okay, so E is like 2.7, let's say. So I think that everybody knows that if I write this, there's a shorthand for that. How's that written? You don't know that? That means they're just a different name for the same thing. So when you write base E, you can write it like this. Okay? So let's write these out when we're using base E. instead of base 2. So this is not log 2x, it's ln x, right? Okay, so we get 2 to the ln, no, sorry, e to the ln x equals what? E to the ln x gives us x, just as those are inverses. And the other one, this one, is ln of e to the x. Ln of e to the x equals x. Okay? So if you do e to the x and then you do ln of x, you get x. And if you do ln of x on e to the x, you get x. Right? Okay? All right, any questions about that? So these are not like really mysterious. These are just that we define ln of x to be the inverse of e to the x. There's nothing else behind that statement. Okay? Okay. So now we've talked about logs. Anybody have any questions about that? Okay. So we said that the log is the inverse of exponential function. And we've talked now, we've made clear what we mean by inverse functions. Pairs, inverse pairs of functions. And we also talked about function composition, which is part of the definition of inverses. Right? Any questions about that? Okay, good. Okay, well, we finished that homework. So maybe, what should we do now? Oh, we can have a quiz. Okay, let's have a quiz. Okay, so let's do, Socrative. Number 527048. 527048. So that's the room number, 527048. Okay, everybody ready? Okay, so the question is, choose the right answer here. So let's label these A, B, C, D and clockwise. So this is A, B, C, D. Okay, everyone get that? A, B, C, D. And the question is, well, I can't show you the question and the answers very clearly at the same time. This is the question. It's 2 times 3 to the x, and then I'll show you the answers. Okay? A, B, C, D. Yeah. What? 527048. Okay, everybody ready? Okay. Okay, everybody either everybody got it wrong or everybody got it right. Because everybody gave the same answer. So what was the answer? A. Okay, good. Okay. All right, let's do another one. Okay, this time. This question. So this is A, B, C, D. Okay? Yes?
My answer is not submitting.
Your answer what?
It's not submitting.
Oh. You can't submit it?
It's still loading.
What does it say?
Nothing.
Nothing?
It's just loading.
Okay. Let's see if it got it. How many people are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well, I don't know what to do. Okay, what's your answer?
C.
Okay, I think that's right. C. Yeah. Okay, that's good. All right, I'll give you credit for that. What's your name?
I wrote my ID number.
Okay. Okay, any questions about those? Okay, one more. Okay, there's that one. What's the inverse of x over 4? Okay? Anybody need any help? Any more time? Okay, I'll give you a little more time. Okay. Give you. Okay. Seems like nobody got this right. Nobody got it right. Okay, let's try that again. So how do you find the inverse? So if this is the function, so you write it, you start by just writing the function, right? And then how do you get the inverse? Switch x and y. So what do you got? Right?